Understanding educational theory can provide real insight into learning. Today we're going to have a look at 10 different theories. These theories are ones that are designed to help both your own learning, but if you're in a position where you're helping others, will give you the right guidance and the right tips to be able to make that successful as well. Let's get started. The forgetting curve is a mathematical formula that describes the rate at which information is lost from memory over time when there's no active attempt to retain it. Ebbinghaus performed intense self-experimentation over many years. To make sure he wasn't relying on prior knowledge or exposure, he created 2,300 nonsense syllables, consonant-vowel consonant groupings like WID or ZOF. He memorized lists of these syllables until he could record them flawlessly. He then tested his memory at various intervals: 20 minutes, 1 hour, 9 hours, 1 day, 2 days, 6 days, 31 days. He measured the savings, the reduction in the repetitions needed to be able to retain it. He found memory loss occurs very quickly, about 50% in the first hour before it starts to level off. To lead your own learning, review notes from a professional development seminar the very next morning before the information decays. Practice a new phrase in foreign language learning 24 hours after first encountering it. To help others lead their learning, send a brief bulleted recap email to your team 24 hours after a major strategy meeting to lock in the key takeaways, or follow up with a new hire the day after orientation to reinforce the most critical safety protocols. Spaced repetition is a learning technique that allows you to review material at increasing intervals over time. This is pre-learnt material that is then reviewed at these subsequent intervals. While Ebbinghaus discovered the curve, it was Wozniak who quantified how to beat it. Through tracking thousands of items over the years, he was able to develop the SM2 algorithm, an algorithm that is used in many apps today. His research proved that the optimal time to review information is at the exact moment you're on the verge of forgetting. If you review too early, it's inefficient, and if you review too late, you've already broken the chain. A key method of spaced repetition is using flashcards. Flashcards that are correctly answered are moved to a box that's reviewed less frequently. Incorrect cards are returned to a daily review box. You can lead your own learning through using digital or even physical flashcards to memorize industry-specific terminology and reviewing the cards at increasing intervals such as 1 day, 3 days, 1 week. Or scheduling 15-minute blocks on your calendar over a month to revisit the manual for a complex new software tool. To lead others' learning, you might consider designing a multi-week training program that actively retests the material from week 1 during the week 3 and week 6 sessions. Or considering a new communication strategy technique that you are looking to implement, bringing it up at each fortnightly meeting to embed it as habit. Schema theory is a framework or concept that helps individuals to organize, process, and interpret vast amounts of information. Schemas act as mental scaffolding. Bartlett's seminal study, The War of the Ghosts, had British participants reading Native American folktale. The story contained a cultural convention, narrative structures, and logical leaps completely unfamiliar to 1930s British society. When asked to recall the story at various intervals, participants fundamentally changed it. They dropped unfamiliar details and changed elements to fit their own cultural understanding or their existing schema. This proved that memory is not a passive recording, but instead is actively reconstructed and governed by existing knowledge. The reconstructive process can be explained through two concepts: assimilation and accommodation. Assimilation is where an existing schema is able to take on the new information. That is, it has the appropriate hooks for this to connect. Accommodation occurs when there is not an appropriate existing schema. Therefore, either the schema changes to accommodate the new information, or as we found in Bartlett's example, the new information was changed to fit the existing understanding. To lead your own learning, or grasp a complex financial concept by mapping it onto a familiar framework of a household budget. To help others with their learning, or explaining a highly technical software update to a sales team by using an analogy related to upgrading a car's engine. Interleaving is where a learner will mix up or interleave multiple subjects or topics while they study in order to improve their learning. This is instead of just simply studying one topic in isolation or as a block. In a landmark 2007 study, college students were taught how to calculate the volumes of 4 different geometric solids. The block group practiced all of the problems of one type before moving to next. The interleave group solved the exact same number of problems, but the shapes were randomly mixed. During practice, the block group performed better than the interleaved, about 89% to 60%. However, on a test 1 week later, the interleaved group obliterated the block group with 63% accuracy versus 20%. Whilst block practice teaches you how to use a formula, interleaved practice teaches you when to use that right formula. You can think about this in your own learning. When you're studying for a professional certification by taking practice tests that mix questions from 3 different modules, which will force your brain to switch gears, or by practicing public speaking by alternating between reading a script, speaking, and answering impromptu questions in one session. To help others with their learning, think about a team building exercise that rapidly rotates between problem solving tasks, communication exercises, and technical challenges. Inductive learning is a process where learners discover rules by observing examples, as opposed to being given that rule up front. It is pattern recognition learning. Cornell and Bjork tested how people learn to recognize the different styles of different artists, a category learning task. Participants viewed paintings by 12 different artists. They were either shown the paintings in mass blocks, all of artist A, then all of artist B, or interleaved, A, C, B, D, A. When later tested on the unseen paintings, the interleaved, or inductive group, was significantly better at identifying the artist's style. Crucially, when they were later asked which method was more successful, 80% of respondents said that it was the blocking. However, the inductive results were much stronger. And the key distinction of this was the ability to discover rules. A deductive approach, or top-down, often means that the rule is established and is easier to see in the examples. When this is reversed and there is no rule, it means that a discriminative comparison approach is required to be able to determine what it is that either connects or is different between them, therefore allowing a greater understanding to be established as those rules become evident. In your own learning, this might look like reading 10 highly successful grant proposals to figure out the structural pattern before reading a how-to guide on grant writing. Or you might spend time looking at dozens of well-designed presentation decks to understand visual hierarchy before trying to build your own. To help others with their learning, you could show a trainee 3 examples of excellent client reports and then ask them to identify the common traits, rather than just handing them the blank template. And it might be working with a team to listen to successful and unsuccessful sales calls to see if they can work out what the best practices are. Cognitive load theory says that our working memory has a strict limit, and that instructional design must be done in a way that encourages learning and doesn't work against it. John Sweller's research differentiated between 3 key kinds of load. Intrinsic, the inherent difficulty of the subject. If the difficulty is too great or not scaffolded appropriately, then it overwhelms the working memory. Extraneous, the way information is presented. Could be confusing diagrams, distracting sounds, too many instructions, and even a change in the procedure to the norm can interfere with this. And then there is the germane, the mental effort required to create schemas, which is the actual learning. Sweller's studies show that for novices, conventional problem solving is heavily taxing on working memory. Providing worked examples, or step-by-step solutions, reduced extraneous load, allowing the brain to focus entirely on understanding the pattern, the germane load, which resulted in faster, deeper learning. To lead your own learning, consider closing all of the tabs, muting your phone, and clearing your desk before attempting to read a dense, complex legal contract. Or breaking down the massive goal of learning to code into tiny, manageable daily tasks. To help others with their learning, design a presentation deck with minimal text, lots of white space, and simple charts so the audience listens to you instead of reading the screen. Or writing a standard operating procedure that eliminates all background history and only lists the absolute essential steps. Dual coding is the theory that human cognition is broken into 2 systems, one that deals with verbal and one that deals with non-verbal, such as images. Alan Pivio conducted numerous recall experiments asking participants to remember lists of words. He found a consistent concreteness effect. Participants remembered concrete nouns, such as chair or apple, much better than abstract nouns, truth or justice. Pivio theorized that this is because concrete nouns are encoded twice, once as a word in the verbal system and once as a mental picture in the visual system. The dual pathway makes retrieval significantly easier. In your own learning, this might look like sketching out a mind map or a flowchart in your notebook while listening to a complex lecture or podcast, or highlighting text in a manual while simultaneously drawing small icons in the margins to represent the key themes. To help others in their learning, it might be providing employees with a written instruction manual and a short visual video demonstrating when rolling out a new physical workflow. Or drawing a diagram on a whiteboard to show the reporting structure of a new department while verbally explaining who reports to whom. The structure of observed learning outcomes. Possibly one of my favourite frameworks to use in the educational space. It's a systematic way of describing how a learner's performance grows in complexity when mastering an academic task. Biggs and Collis analysed hundreds of student responses across history, math and geography. They found that they could reliably classify answers into 5 stages. The first being pre-structural, misses the point entirely. Then unistructural, they can identify one relevant fact. Multi-structural can list several independent facts. Relational can link the facts together and explain how they interact. And extended abstract, they can take this integrated understanding and apply it to a completely new, unseen domain. This is also known as high-level transfer, which is a common goal in education. To lead your own learning, you can use this framework to consider ideas such as, do I just know the buzzwords of the new industry trend? Or can I explain how it actually impacts my specific role? Or perhaps assessing your own coding skills. Can you write a single script? Or can you build a system where multiple scripts interact? And when helping others to lead their learning, you could consider giving feedback that praises a team member for gathering the data, but then challenge them to synthesize that data into a strategic recommendation. Bloom's taxonomy is a hierarchical framework used to classify educational learning objectives into levels of complexity and specificity. The original 1956 taxonomy was a one-dimensional list of nouns, knowledge, comprehension, application, but the 2001 revision by cognitive psychologists shifted these to active verbs: remember, understand, apply, analyze, evaluate, and create, and added a second dimension to this as well, the knowledge dimension: factual, conceptual, procedural, and metacognitive. This acknowledged that learning is an active intersection between what you know and how you use it. In your own learning, it might be instead of just remembering the keyboard shortcuts, that you actually create a macro that improves your workflow. Or instead of understanding a new marketing theory, you actually evaluate your old one to see what the differences and the flaws might be in it. And when helping others learn, it might be that you're designing a workshop not just where they listen or understand, but they're actually involved in working through a difficult scenario, that ability to apply, but maybe also create their own solutions as part of that process. Desirable difficulties is where you introduce specific engineered challenges into the learning process, slowing it down, ultimately causing a bit of frustration, but finding that actually longer-term retention and understanding is improved. Ray Diger and Karpik's famous testing effects studies had students read prose passages. One group restudied the text through passive review. Another group was given a blank piece of paper and asked to recall as much as possible in the form of retrieval practice. 5 minutes later, the restudy group performed better, but 1 week later, the testing group massively outperformed the restudy group. Passive reading creates a fluency issue. It feels easy, therefore you feel like you know it. The struggle of retrieval builds actual mastery. Another interesting outcome of this showed that testing was a valid form of learning, not simply just assessing. For your own learning, this looks like closing the book after reading a chapter and forcing yourself to write down the 3 main takeaways from memory in the form of active recall, or attempting to troubleshoot a technical issue yourself at 15 minutes before looking up the solution in the company knowledge base. To help others with their learning, use low-stakes closed book quizzes that promote that active recall process. This is a big improvement and simply just asking, does everyone understand? Building an understanding of these educational theories will be to your advantage, whether it's for your own learning or to help others. Understanding the difference between inductive learning and deductive learning, realizing that the working memory has limits and that we must adhere to these. All of these things will make you a better teacher and a better learner. Take some time to review them, see where they apply for you, and let me know which of these is going to be your next one that you try.